Okay, here goes. Well, I guess the first thing is what are measures of central tendency? And the measures of central tendency we're going to discuss are the mean, the median, and the mode of a data set. So we'll be given some data set that has some format, and we're going to identify the mean, the median, and the mode of that data set. So let's talk about what each of those terms represents. First, the mean. The mean is the thing that you commonly know as average. Um, we're going to talk about the word average here in a few minutes, but the mean is the thing that if you were just in conversational language, it's what you would describe as the average. It's when we add them all up and divide by how many there are. I'm going to give you a formula for the mean, and you may not feel like a formula for the mean is necessary, but it will come in handy in some of the problems that we solve that aren't just find the mean type of problems. And you'll see those later today too. An abbreviation that we can use for mean is X with a line over it, and we'll call that X bar. That's X with a line over it, and it's an abbreviation used to represent the mean. And that's going to be the sum of all the data points divided by the number of data points. Add them all up and divide by how many there are, but a little more formally, the sum of the data points divided by the number of data points. The next measure of central tendency we're going to look at is the median. And I mentioned that the median on exam 2 was an A, and maybe you already knew what the median was, maybe not. Well, now we get to talk about that. The median is the middle number in a data set. Now, it's really important to note that it's the middle number, not just however they were given to us in some random order. The median has a specific meaning. It's the middle number when we arrange the data set from lowest to highest. So before we find the median, we're going to arrange the data set from least to greatest, from lowest to highest, and then the one that's in the middle is the median. Finally, we have the mode. And what the mode is, it is the most common data value. So for example, if we have a data set that's 1, 3, 3, 7, the data point that occurs the most often in there is that 3. And so the mode for this data set would be 3, because it occurs more than any other data point in that data set. Now, if we change the data set just a little bit and we add another 7, and now we're looking at it and we're like, well, what do we do if these two are like tied for the most common? What do we do with that? Well, we would actually call that data set bimodal, and it would have 2 modes. Three and 7 would both be the modes. And then some of you may be thinking, okay, what if you added another 1? Do you have 3 modes? No. Once we get past bimodal, then at this point, when there's 3 data points that all occur the same amount, at that point, we would just say there is no mode. And that would be true if our data set was just 1, 3, 7. They all occur the same amount of times. There's no mode. So that's what happens if there isn't one, or if there's more than 2, we just say there's no mode. One thing I mentioned when we were talking about the mean is it's what you would commonly know as average. We're not going to use this word for that anymore because technically, statistically speaking, any one of these can be called the average. You could say average and be talking about the mode. You could say average and be talking about the median. You could be talking about the mean, but if somebody's talking about statistics and they say average, it can be any one of these. It doesn't have to be the mean. And what it is because the word average in here means typical. So The average is a number that is typical of the data set, and that could be the mean, it could be the median, or it could be the mode. We'll talk a little bit about using statistics to share your point of view, and this is one of the ways that that can be done, is by using one of these terms that suits you best and calling it the average. For right now, I just want to make sure you're comfortable with the idea that we have three measures of central tendency: the mean, add them all up and divide by how many there are; the median, the number in the middle when we've arranged them from lowest to highest; and the mode is the one that occurs most often. Does anybody have questions about any of those terms? That's sort of what gets us started today, is just those terms. Okay, let's look at a data set. Find the mean, median, and mode for the following data set. Round the mean to the nearest 100. So we've been given this data set, and our job is to find the mean, the median, and the mode for this data set. We'll just tackle those in order. First, we'll find the mean. The mean here is what I get when I add them all up and divide by how many there are. So that's going to be 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7 divided by, let's see, 1, 2, 3, 4, 5, 6, 7. I have 7 data points here, so we'll divide by 7. Let me know if you see something that's unclear or doesn't make any sense. When I add these up, 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7, and I've got 34 over 7. We'll divide that, and I get 4.85714. That keeps going. I was told here to round to the nearest 100th, so that's what we'll do. Nice little review of rounding. We haven't done it in a little while. Shake off those cobwebs. So we find the hundreds place, we look one space to the right. That number is 4 or bigger, so we'll round this up to 4.86. And that's the mean of our data set. Up next, we need to find the median. Now, finding the median, it's really important to remember that if we're going to find the median, we need to write these from lowest to highest. Because we've just been given these in some random order. The one that's in the middle now doesn't really mean a thing. Once we write them from lowest to highest, that's when we're going to find the median. So let's do that. The lowest I have is a 2. Then I have 2 3s. I want to make sure to include both of those. Then I have a 4. Then a 6, a 7, and a 9. I had 7 data points. I'm going to make sure I have all 7 here. Let's see. 1, 2, 3, 4, 5, 6, 7. Yep, I have all 7. Doesn't guarantee I wrote them down exactly right, but I feel pretty good about the fact that I have the right numbers if I have the right number of numbers. All right, now I need to find the median, the one in the middle. And I look at this data set, and what I can see here is that there are 7 data points. That's an odd number. What that tells me, once I have an odd number, is there is going to be one right smack in the middle. There's going to be one number right in the middle, and there's going to be 6 other data points. This may feel a little simplistic, but trust me, it'll be really important for us pretty soon. And if it doesn't feel simplistic, if you have questions about it, let me know. We have 7 total data points, which is an odd number, which means there's going to be one in the middle, and then there's going to be 6 other data points. So that we find the one that's in the middle, half of those are going to be below the median. So 3 numbers will be below the median, and half of those other numbers, 3 of them, will be above the median. So when I look at this data set, what I've got here then is a structure like this: 3 that are below the median, 3 that are above the median, and the median right smack dab in the middle. If that isn't clear or doesn't make sense, please let me know. Now I'm going to go section off my data set based on this. So I have 3 that are below the median, 3 that are above the median, and so the median that I was trying to find is right there in the middle. It's 4. So the median of this data set is 4. Finally, I need to find the mode. Mode is probably the easiest of these. It's just whatever number occurs most often. What number occurs most often in this data set? Somebody let me know. 3. All right, let's see. As I look at my data set here, it's kind of nice when it's written from least to greatest, from lowest to highest. I can see, well, those 3s are grouped together. There's more of those than there is anything else. So the mode is 3. One thing important to note about the mode, the fact that there are 2 3s, we're not going to report anything about the fact that there are 2 of them. It's what number occurs most often. 3 occurs most often, so that's what our mode is. I've got one more example I want to do before I have you try one. Find the mean, median, and mode for the following data set. Round the mean to the nearest hundredth. So it's very similar to the last question, the way this one is structured. The first thing we're going to do is find the mean. And we're going to find that by adding them up and dividing by how many there are. So it'll be 12 plus 9 plus 4 plus 8 divided by 4. And let's see, 12 plus 9 plus 4 plus 8 is 33 divided by 4. And I get 8.25. I was told to round to the nearest hundredth. Well, this already is. So 8.25 is the mean of this data set. Up next, we're looking for the median here. The median is going to be the number in the middle once I've written them least to greatest. So I need to do that first. So I'm going to take these and write them from least to greatest. That'll be 4, 8, 9, 12. So I've written them from least to greatest. One thing that I can see here is that I have 4 data points. This is an even number. Might raise some questions for you, and that's okay, because when we had an odd number of data points, there was going to be one sitting right there in the middle for us to choose as the median. But with an even number of data points, there's not going to be one right in the middle. There's not going to be a number right in the middle. I have 4 data points, so 2 of them are going to be lower than the median, 2 of them are going to be higher than the median. How in the world are we going to find the median? Well, let's take a look. We're going to go ahead and section that off, and I'm going to have 2 down here and 2 up here. What I do now to find the median, because keep in mind what the median means. The median is in the middle of my data set. I'm looking for a number to represent the middle of my data set. So what I'm going to do next is I'm going to find the 2 numbers that are closest to the middle, and I am going to find the mean of those. The mean of these 2 numbers, and that will be the median of the data set. Essentially, what we're finding is what's halfway between these, that's going to be the middle of the data set, and that's going to be the median of the data set. And so to find the mean of those, we can do 8 plus 9 over 2. That's 17 over 2. That's 8.5. And if some of you said, well, halfway between 8 and 9, that's going to be 8.5. Excellent. Great. You can absolutely do that. If you're more comfortable writing it down this way, there's absolutely nothing wrong with doing it. It just takes a second. And now we've found the median of our data set. The median of this data set is 8.5. Sometimes students will ask, wait a minute, how can this be your median? That's not one of the data points. And my response to that is, well, nobody seemed to have a problem when the mean wasn't one of the data points. And that's perfectly fine. The mean doesn't have to be one of the data points. The median doesn't have to be one of the data points either. It's a number that represents the middle of our data set. If it's one of the data points, great. If it's not, that's okay too. Finally, here we need the mode. What's the mode of this data set? And I guess what I'm saying then is, if you were asked for the mode, what would you give? Perfect. There is no mode. That's exactly right, Ashley. Thanks for that. I know getting back in the swing of things after spring break, we're not that, we're kind of shaking the cobwebs loose to get ourselves um, back in the swing of class. But yes, that's exactly right. There's no mode here. They all occur the same number of times, so there is no mode. Does anybody have questions about what we did in those two before I have you try one? All right, here goes. Find the mean, median, and mode for the following data set. If necessary, round the mean to the nearest hundredth. I'm going to make a poll for this. The poll is just going to be mean and median. I won't put the mode in there. So the poll is going to be for the mean and the median. I want you to find both of those. This is absolutely the type of question you can expect to see in homework, on a quiz, on an exam. So see how this goes, and we'll identify any difficulties you might be having. So for the mean, add them all up, divide by how many there are. For the median, we're looking for the middle number. But remember, we want to write these from least to greatest first, then find the median. Let's go another 30 seconds on this, and then we'll talk about it. If you need more time, let me know. All right, let's see where we are on this. Okay, unanimous. Very good. Not everybody did the poll, but that's okay. We're unanimous. If you see something that you're not sure of or you want to ask about, make sure you let me know. Here goes. The first thing we're going to do, we are going to find the mean for this data set. And so we're going to add them up. That'll be 3 plus 4 plus 8 plus 2 plus 4 plus 7 over however many data points there are. 1, 2, 3, 4, 5, 6. And let's see, 3 plus 4 plus 8 plus 2 plus 4 plus 7 is 28 over 6. We'll divide that and have 4.66666, and that keeps going. We were told to round to the nearest hundredth. So we'll round to the nearest hundredth. Look one space to the right. That's 5 or bigger, so we'll round this up to 4.67, and that's our mean. We were unanimous in the poll, which is excellent. So if you have questions, you let me know. For the median, we can see that we have 6 data points, which is an even number, which means there will not be one in the middle. There will be 3 data points lower than the median and 3 data points higher than the median. Of course, before we go to look for the median, we better write this least to greatest. We don't want to just go up here and look for it because those haven't been written from least to greatest yet. So we'll rewrite this, and let's see, we've got 2, 3, a couple of 4s, 7, and 8. Now we can section it off so that we have 3 lower than the median and 3 higher than the median. And now to find the median of this data set, we find the 2 numbers that are closest to the middle, and we need the mean of those. If you want to do 4 plus 4 over 2, you absolutely can. Or if you want to say, well, the mean of 4 and 4, halfway between 4 and 4 is just 4. That would be exactly right. And so the median of this data set is 4. Finally, the mode. We haven't done the mode for this yet. The mode is the one that occurs most often. There's 2 4s, so the mode here is going to be 4 also. Poll went great. Let me know if you have any questions on that. Definitely the type of question you can expect to see on a quiz or an exam. Okay. A little bit of a review topic mixed in here. It's the idea of using multiplication instead of repeated addition. And what I mean by this is if we wanted to add these numbers, 1, 2, 3, 4, 5, 6, if we wanted to add 7 5s together, we could do 5 plus 5 plus 5 plus 5 plus, but we probably wouldn't. Instead, we would multiply. Well, if you look at this, you have 7 5s here, so it's really just 7 multiplied by 5. And adding them up would give us 35, which is the same thing we get when we multiply. And this may feel a little obvious, but it's going to be really important for us here in just a minute, that instead of adding up all of those 5s, we could just multiply to get the sum of them. Here's where this is going to come in handy for us. It's a different way to see data presented, and it's called a frequency table. There. The number of students in classes at a school was counted with the following results. So what was happening is the principal was walking around the building with the clipboard, writing down how many students he saw in each classroom. And the way that this frequency table works, the information it gives to us is what he saw was he saw 15 students in 3 of the classes. He saw 22 students in 7 of the classes, 28 students in 5 of the classrooms, and 40 students in 2 of the classrooms. Essentially, what we've got here is these are our unique data points, And the frequencies are how many times each of these data points occurs in the data set. It's really important to understand how frequency tables work. This is something that is sometimes challenging for students. So I want to be patient and careful here, and I want you to ask questions whenever you have them. A key here is that we don't just have these 4 data points and that's it, because of the number of times they appear in the data set. This frequency of 3 tells me that 15 occurs in the data set 3 times. And this 7 tells me that 22 occurs in the data set 7 times. So there's 7 of these 22. So if I wanted to write down the entire data set, I could. But that's kind of the beauty of this frequency table. This frequency table allows me to see the entire data set without having to write out every single individual data point. Great when we have a whole bunch of data points that are the same as each other, like we do here. This data set is made up of 3 15s, 7 22s, 5 28s, and 2 40s. Are there any questions about that, about what we see here in this frequency table at this point? We are going to do the work of finding the mean, median, and mode, but just reading it in general. If there are any questions, don't hesitate to ask them. Okay, first thing we want to find here is the mean. So let's do that. Let's find the mean. So our mean of this data set is going to be add them up and divide by how many there are. All right, well, let's see. Mean then. Add them up and divide by how many there are. So the mean. I could do 15 plus 15 plus 15, but instead, I'm going to do 3 times 15 because I have 3 15s in my data set. I could do 22 plus 22 plus 22 plus 22. No. We don't want to do that. Instead, if I want to add up all those 22s, I can just do 7 times 22 and 5 times 28 and 2 times 40. We're multiplying the frequency by the data point. Then we're going to divide by how many there are, because that's how we find the mean. Add them up, divide by how many there are. Be a little bit careful here. There are only 4 unique data points, but there are more than 4 data points in this data set. If we want to know how many data points there are in this data set, what we're going to do is we're going to add up those frequencies. 3 and 7 is 10, 15, 16. There are 17 data points. Because I have 3 of these, 7 of these, 5 of these, and 2 of these. And so because of that, I have a total of 17 data points. So when I go find the mean, I need to divide by 17. Please let me know if you have any questions about that. Okay. Let's simplify this thing and find our mean. So we have, and this would be a little clumsy on the page, but 3 times 15 will be 45 plus 7 times 22. I don't trust myself on that one. 154 plus 5 times 28 is 140 plus 2 times 40, all divided by 17. Then we need to add those. 45 plus 154 plus 140 plus 80 is 419 divided by 17. We'll divide that, and we're told to round to the nearest hundred, so we'll go ahead and do that here, and it'll be 24.65 will be our mean. Let me know if you have any questions about anything that just happened there. We're going to do the mode next. The mode of a frequency table is great. It's just the one with the highest frequency. Whichever one has the highest frequency is the one that occurs the most. Highest frequency is right here, so the data point that occurs the most is 22. So the mode of this data set is 22. Make sure that you report the 22 as the mode, not the 7. The 7 is just how many times it shows up. That's not what's the mode. The mode is the actual data point that occurs the most, which is the 22. Any questions about either of those things before we get into finding the median on a frequency table? As far as measures of central tendency go, as far as mean, median, and mode type of questions, finding the median from a frequency table is the most challenging thing we'll do. All right, here goes. So if I want to find the median from this frequency table, the first thing I need to know is how many data points there are, and there are 17 data points. That's an odd number, which means there will be one right in the middle. And there'll be 16 other data points. Half of those, 8, will be lower than the median, and half of those 8 will be higher than the median. So the way that this data set shakes out, 17 data points, is like this. 8 that are lower than the median right there in the middle, and 8 that are higher than the median. Any questions about that? Great. We're doing fantastic then. Okay, so when I go to find the median here, if I start counting from the lowest data point, data points 1, 2, 3, 4, 5, 6, 7, and 8 are going to be lower than the median. And as I count from least to greatest, it is the 9th data point that I get to that's going to be the median. So that's how I'm going to find it. I'm going to start at the lowest data point and start counting towards the highest. When I get to the 9th one, that's the one that's in the middle. So I have 3 15. So that'll be data points 1, 2, and 3, counting from lowest to highest. And then I have 7 of these 22s here. Well, that's going to be data points 4, 5, 6, 7, 8, 9, and 10. Just to finish off the idea here, I'm going to keep going, even though to find the median, we've done enough, but I'm going to keep going just to finish it. The next 5 data points are here. That would be data points 11, 12, 13, 14, and 15. And then the last 2 data points are here. That would be 16 and 17. So counting from least to greatest, data points 1, 2, and 3 are 15s. Data points 4, 5, 6, 7, 8, 9, 10 are 22s. Data points 11, 12, 13, 14, 15 are 28s, and 16, 17 are 40s, if I were to list them all out. What I was looking for here to be the median was the 9th data point. The 9th data point is a 22, and so the median of this data set is 22. The next thing I'm going to have you do is try one of these. If you have questions before you try one, please ask them. Otherwise, if you feel like you're ready and you want to do it, that's fantastic. Okay, here goes. The number of animals at different shelters are as follows. We're given a frequency table where we know the number of animals and the frequency with which that number occurs in our data set. So the frequency always tells us how many times the data set occurs in the data set. The actual data points are in the other column. Here, I want you to find the mean, median, and mode of this data set. And I'm going to make a poll for this. And just like the last one, I'm going to ask for mean and median. We'll also find the mode. But as far as the poll goes, just mean and median. Take your time on this. We don't need to be in a hurry. And I want to be patient enough to give everyone a chance to try it, primarily because I do think finding the median from a frequency table is probably the single most challenging thing we'll do with measures of central tendency. And again, this is definitely the type of question you could expect to see in homework, on a quiz, on an exam. Um, so if you are having any difficulties, let's make sure we get those fixed. Let's go another 30 seconds on this and then we'll talk about it. If you need more time, let me know. All right, let's take a look and see where we are. Okay, unanimous again. That's excellent. I'm thrilled with the way those polls have gone today. All right, so let's go ahead and work through this. If you see anything you want to ask about, make sure you do that. The first thing we'll do here is find the mean, which is add them all up and divide by how many there are. And so that'll be 5 times 20 plus 4 times 50 plus 1 times 100 plus 1 times 900. And we're going to divide that by, be careful here, we're not going to divide by 4. Our number of data points is 5 and 4 is 9, 10, 11 data points. So we're going to divide by 11. 5 times 20, 4 times 50, 1 times 100, 1 times 900, all divided by 11. Let's see, 100 plus 200 plus 100 plus 900 is 1,300 divided by 11. And we're going to round that to the nearest whole number. And this one says round to the nearest whole number, probably because it's animals in shelters. So a whole number is probably a more reasonable answer than something involving a decimal. Rounding to the nearest whole number means we're rounding to the nearest ones place. So let's see here, we've got 118.1818, and that keeps going. And we don't round to the nearest whole number very often. That's why I'm being so explicit here. We find the ones place, that's the nearest whole number. Look one space to the right, that's 4 or lower. So we'll round this down to 118 to be our mean. We'll do the mode next. Um, let's see, the mode here is just the one that occurs the most. That's the one with the highest frequency, and the data point with the highest frequency is 20. And let me know if you had questions on finding the mode there. And then finally, we need to find the median. In this data set, when we go looking for the median, there are 11 data points. That's an odd number. So there will be a data point right in the middle, and there will be 10 other data points. Of those 10 other data points, 5 will be lower than the median and 5 will be higher than the median. And so when we go to find the median, we start counting. We count from the lowest, we count 1, 2, 3, 4, 5, and then it's the 6th data point we get to that's going to be the one right in the middle. And so let's see here. My data points 1 through 5 are all going to be 20s. And then the next 4, 6, 7, 8, and 9 are in there. And then data point 10, data point 11, just to be complete. You don't have to fill those in. What we were looking for was the 6th data point. And the 6th data point is one of these 50s. So the median of this data set is 50. Let me know if you have any difficulties, if you had any problems with that. The poll went great, so I feel like you're in a really good place with a concept that can be difficult. So that's fantastic. But please let me know if you do have questions. One thing I want to mention about this particular problem that we just solved is the impact of outliers. An outlier is a number that doesn't really fit with the rest of the data set very well, but it has an impact on the measures of central tendency. If you look at the data we've been given here about the animals in these shelters, there are 5 shelters that have 20 animals, 4 shelters that have 50, one shelter has 100, and then this one shelter has 900. That number is not really like the others. And what that outlier does is it has a really powerful impact on the mean. Because if you look at this, the mean that we calculated here, the mean that we came up with is 118. And I don't know that if somebody asked you what's a typical number of the animals in these shelters, it wouldn't be wrong for you to say that the mean value is 18, or excuse me, 118. But I don't know that that's really representative of what's going on, because there's only one shelter with more animals than that in it in this whole data set. What happens is this 900 pulls the mean up to a really high number. For this reason, a lot of times you'll see data about things reported by using the median. Because the median is very stable. It's not that the median is necessarily better, it's just stable. The median isn't impacted by outliers that way. The median's just the number in the middle. If that data point were 900, 9,000, or 90,000, the median wouldn't change. The mean would blow up huge, but the median wouldn't change. The median's a very stable number. If you see housing data, it's often reported as the median. You could drive through a neighborhood and there's a $400,000 house on one side, a $300,000 house, and there's a $500,000 house and another 400 and another 400. And then at the end of the street, there's an $8 million house. Well, if you found the mean of the houses, it would be some huge crazy number that really wouldn't represent that neighborhood very well. And it's because that $8 million house, that outlier, changed the value of the mean. That's why you'll see median reported a lot, is because it's very stable. It's right in the middle, regardless if you have a crazy number mixed in there somewhere. All right. Along with measures of central tendency, we're also going to talk about weighted averages today. Weighted averages are things where there's something involved in here that counts more than something else. Not every component counts equally. GPA is a beautiful example of weighted average. Um, Here we have a student that's taking a 5-credit math class, a 1-credit science class, and a 3-credit history class. The weighted part of this is here in the credits. Because this math class is worth 5 credits, it carries more weight than this science class that's only 1 credit. And so that's how GPA becomes a weighted average. You may be familiar with the idea that when you take a class and you get a grade in it, you get a certain number of grade points per credit. And A is worth 4 points per credit, a B is worth 3 points per credit, a C is worth 2 points per credit, a D is worth 1 point per credit, and a F is worth 0 points per credit. And pluses and minuses factor in here also. There is a chart in your book on page 196 of these of grade points. It's page 196 that shows the values for plus and minus also. But for right now, we're just going to keep it simple and stick with ABC just to kind of see how this works. And so you might look at this and sort of at first glance say, well, they've got an A, a B, and a C, so that's a B average, that's a 3.0. Well, it's actually a little bit more involved than that, and it's because courses with different credits carry a different amount of weight. Let's see how we would calculate the grade point average for this student. First, it's important to note that grade point average is found by taking the number of grade points that a student has earned and dividing by the number of credits that they have taken. So that's sort of our formula for GPA, is its grade points divided by credits. So what we're going to have to do here is figure out how many grade points this student earned. Okay, so let's figure out how many grade points they earned. This student took a 5-credit class and they got an A in it. An A is worth 4 points per credit. So they get 4 points per credit. So we're going to multiply those, and that 5 times 4 is going to give them 20 grade points for that math class. That 5-credit A is worth 5 times 4, or 20 grade points. This 1-credit science class, they got a C in. A C is worth 2 grade points per credit. So we're going to multiply those together. And 1 credit times 2 points per credit, they earned 2 grade points for that science class. And then let's see, this 3-credit history class, they got a B. A B means they earned 3 points per credit. So we're going to multiply those together. 3 credits times 3 points per credit, they earn 9 grade points in that history class. So altogether, adding those up, they've earned 20 plus 2 plus 9. They've earned 31 grade points. And the number of credits, let's see, 5, 6, 7, 8, 9. They're taking 9 credits. So we'll divide by 9. And 31 divided by 9 gives us, rounded to the nearest hundredth, gives us 3.44 as the GPA for this student. At first glance, without knowing about weighted averages, you might have said, well, an A, a B, and a C is a B average, that's a 3.0. But this 5-credit A pulled them up so that instead of a 3.0, they have a 3.44. That's where you see the weight of that 5-credit class is getting an A in it, pulled their grade up from just ABC is a B average. Are there any questions about what we did there to calculate the grade point average for a student? And just so you know, this is exactly how your GPA is calculated. It's grade points divided by credits, and it's exactly what we just did there. All right, let me have you try one. Find the GPA rounded to the nearest hundredth. for the following student. In math, they got a 5-credit B. In science, they got a 4-credit C. In history, they got a 2-credit A. And just as a reminder, an A is worth 4 points per credit, a B is worth 3 points per credit, a C is worth 2 points per credit, and that's all we need for this particular problem. All right, I'll give you a chance to calculate this GPA and I'll set up a poll for it. Here again, this is definitely the type of question you can expect to see in homework, on a quiz, on an exam, is using a weighted average to find a GPA. We can go 30 more seconds on this. Let me know if you need more time. All right, let's see where we are on this one. Almost unanimous, not quite, but very close. As we go through it, if you're not sure where a mistake happened, make sure you let me know. All right, so we're supposed to calculate the GPA for this student, and we remember that GPA is grade points divided by credits. So what we're going to have to do is figure out how many grade points this student earned. And let's see here. We have a 5-credit B. A B is worth 4 points per credit. So we're going to multiply those together. And 5 times 4 is going to be 20 grade points from that math class. We have a 4-credit C, and a C is worth 2 grade points per credit. So we're going to multiply 4 times 2 and see that they earned 8 grade points for that science class. We have a 2-credit A, and A is worth, oh, I messed this up. Nobody caught me. I got to back up. I gave him 4 points per credit for that B. That's no good. Y'all should have called me out on that. All right. How about that B is worth 3 points per credit, and we're going to multiply 5 credits times 3 points per credit, and they earned 15 grade points for that math class. Y'all are allowed to tell me when I make a mistake. It's perfectly fine. All right, we have a 4-credit C. A C is worth 2 grade points per credit. We're going to multiply those together. 4 credits times 2 grade points per credit is 8 grade points for that science class. And then a 2-credit A, which is 4 grade points per credit. So we're going to multiply those. 2 credits times 4 grade points per credit is 8 grade points in that history class. So the total number of grade points, we'll add that together. 15 plus 8 plus 8 is 31. So 31 grade points. And this particular student has taken 5 plus 4 is 9 and 2 is 11 credits. And so we'll divide. 31 divided by 11 is 2.82. So the GPA for this student is 2.82. Other than my goof there early in the problem that we got fixed up, if you have any questions about how we solved that one, let me know. That's how we calculate a grade point average using a weighted average. And the weighted part here is they have an ABC, which you could say, well, that's a B average then, 3.0. But what happened here is this 2-credit A didn't carry as much weight as this 4-credit C did. And so that 4-credit C pulled them down lower than the 3.0 would be. Okay. Early on, when we first talked about the mean, I said, I'm going to give you a formula for this. Even though it's add them all up and divide by how many there are, I'm going to give you this formula anyway because it may come in handy for you later on. And we've reached that point now. We're going to look at some problem solving that involves the mean. And the formula that we had for the mean is going to be really helpful. Here's what I'm talking about. A small used car lot carries an inventory of 20 cars. The mean value of the cars in this lot is $8,000. What is the sum of the values of the cars? So you might read this and your first thought is, well, how am I supposed to know how to get the value of adding up all the cars? Because I don't know what any of the cars is worth. And that's true. I have no idea what any car in this whole lot is worth. But what I do know is that there are 20 of them and that the mean value is $8,000. Combining that with the fact that I know the mean is the sum of the data points divided by the number of data points. Okay, so let's see what we can do here. I know how to find the mean. And in this particular problem, I'm not trying to calculate the mean. I was given that the mean was $8,000. Okay, so the mean's $8,000. And then that's equal to the sum of the data points. Well, that's what I'm trying to find. So I don't have that divided by the number of data points. Oh, well, the problem told me there's 20 cars. So there are 20. We've seen this happen before, especially with the formula for like simple interest, where if I know every piece except for one, I can find the missing piece. Up until now, we've had the sum and we've had the number and we've calculated the mean. This problem's a little bit different than that. This time, we know the mean, we know how many data points there are, and it's the sum that we're looking for. We have to remember a little bit of algebra. We don't do a ton of algebra, we do it from time to time. Here I have sum divided by 20. What do I need to do to make divided by 20 go away? So that I can get this sum by itself. What do I need to do to make divide by 20 go away? Excellent, Kevin. Thanks. Jessica's right behind you, I'm pretty sure. And again, multiply by 20 on both sides. Perfect. So I'm going to multiply by 20 on the right. What that's going to do is get this to cancel, leaving me just the sum. That's what I'm looking for. If I multiply by 20 on the right, I also need to multiply by 20 on the left. And when I do that, 8,000 times 20 is 160,000. And that is the sum of the values of the cars. That's what I was looking for. So if I'm, insurance guy and I want to know how much insurance this owner better have on their used car lot, they better have at least $160,000 because that's what the values of the cars are. I have no idea what any individual car is worth. I just know that if you add them all up, they're worth $160,000 altogether. And that's how this formula can be really useful for us. If we know two of the three pieces, we can find the third piece. Here's another problem that works in a similar fashion. Josephine has taken 4 exams in her math class, and she has a mean score of 88. There's 1 exam remaining before her final grade is determined. What score will she need on that last exam in order to finish the class with an overall mean of 90? So what's going on here is this. We're almost to the end of the semester. Josephine's taken 4 exams in her math class, and her mean is 88. There's 1 exam to go, and she wants to finish with an A. She wants to get her overall mean to be 90. What score does she need on that last exam to get a 90? We're not going to do this with trial and error, although I suppose you could. Instead, the way that we're going to look at this one is we are going to look at how many points she's earned so far. And we're going to keep in mind this main idea here that, let's see, the mean is the sum of the data points divided by the number of data points. So with that in mind, I don't know any of her exam scores, but what I know is she's taken 4 exams and she has a mean of 88. So we're going to put this formula to work for us here. Her mean is 88. I don't know how many points she's earned, but she's taken 4 exams so far. I don't know what any of her exam scores are, but if I added them all up and divided by 4, I would get 88. That's how we arrived at that mean. Please let me know if you have any questions about how anything's getting set up here. Just like we did in the last one, we're trying to get sum by itself. So we're going to multiply by 4 on the right so that these cancel. We're going to multiply by 4 on the left. And what that does for us, 4 times 88, that lets us know that so far in this class, she's earned 352 points. All right, now we need to examine what does she need? Well, she wants to finish the class with a mean of 90. So she wants her mean to be 90. We don't know what the sum of the points is, and here's probably the key part of this question is the number that's going to go down here. After she takes that one more test, and we're at the end of the semester, how many tests has she taken? What number is going to go in that circle? 5. Excellent, Ashley. And Kevin's probably right behind you with a 5, which is, and if not, that's okay too, because we could talk about it. There's a little bit of an instinct to want to put a 4 here, but 4 is the number of exams she's taken so far. She's going to take 1 more, and at this point, she will have taken 5 exams. Okay, to figure out the sum that she's going to need, we're going to have to multiply by 5 on the right, multiply by 5 on the left. Those will cancel. And now we can find out that 5 times 90 will be 450 is the sum that she's going to need. So right now, she has 352 points. She's trying to get to 450 points. So in order to bridge that gap, we need to find the difference between those. We need to subtract 450 minus 352. She's going to need a 98 on that last exam in order to have enough points to have an overall mean of 90. Like, wow, that's an awfully high score just to pull her grade up 2 points. Well, There's sort of the idea of a weighted average embedded in here. There are 4 exams with a mean of 88. That's going to carry more weight than this one exam at the end. So this one exam is going to have a pretty high score on it to pull her up to a 90. Any questions about what we did on that one? Is there anything in there that you're unclear about or might not have made sense? Awesome. All right, one more to go. A morning section of a class consists of 18 students, and their mean score on an exam was 88. An afternoon section of the class took the same exam, and those 24 students earned a mean score of 81. What's the overall mean score for this exam? So you're a teacher and you want to know what your overall mean is, and you calculated the mean for the morning class and it was 88. And then you calculated the mean for the afternoon class and it was 81. You want to know what the overall mean all together is. There's a little bit of an instinct to want to go, well, I'll just take the two means and add them up and divide by 2. That doesn't work, again, because there's a little bit of a weighted average built in here. There are more students in the afternoon class than there are in the morning class. So we don't want to just add them up and divide by 2 because that would treat the morning and the afternoon equally, and we don't want to do that. We want the overall mean score. A great way to approach this type of question is by using a frequency table. We can look at the score that was earned and the frequency of students that earned it. In the morning class, their mean score was 88 and the frequency was 18. That's how many people were in there. Now, you might be thinking, well, wait a minute, we don't know if anybody earned an 88. And that's true, we don't. What we do know, though, is that if 18 students took the exam and the mean was 88, that if we added up all their scores, it's going to be 18 times 88. And that's exactly what we're going to do here when we go to find the mean overall. So it's true that we don't know any of the scores, but if we want to know how many points came from that morning class, we can treat it as though all 18 of them scored 88, because that'll give us the same value for the sum. We do the same thing for the afternoon section then. Their mean score was 81, and there were 24 students in there. And now we're back to doing something we're really comfortable with. That's finding the mean from a frequency table. So we want the mean here, and that's going to be, well, I have 18 times 88 plus 24 times 81. And be a little careful here. We want to make sure we're dividing by the right number. The number of data points we have here is, add up the frequencies, 42. So we're going to divide by 42. And now we can simplify this. 18 times 88 is 1,584. And it's not really important that you know this, but that's the total number of points earned in the morning class. We don't know what any of the scores were, but we know all together they add up to 1,584. 24 times 81 is 1,944. That's all the points earned in the afternoon class. And we'll add those together and have 3,528 divided by 42. Dividing those will give us the overall mean of 84. How about that? Came out to a whole number, 84. And so the overall mean here would be 84. Not the same thing you would get if you just did 88 plus 81 divided by 2. So we want to make sure we count everyone who took the exam, and the way that we do that is by looking at 42 data points here instead of 2.